Hey guys, welcome to the live stream. We have a fairly interesting topic today, the art of testing. Frankly speaking, I was very surprised to see that so many people voted about unit testing and integration testing and the art of testing in general because I actually did a lot of lectures and a lot of videos about testing in general. And it's kind of surprising to see that so many people do not understand the topic or are wishing to see this topic in particular instead of something else. But well, testing is a very important topic, so it's a good to know that so many people want to learn it or want to improve at it. I've prepared this live class to have more coding and less theory because usually people understand the theory or you can learn the theory by reading online. You can see a lot of well, in a demo code a lot of the things look like easy, look like very testable, look like without any strong dependencies. You don't have that much spaghetti code, and actually it looks way more easy in theory than in practice to assert something or to refactor something so that it becomes testable. So it's a good topic to cover because if we manage to make our code more testable, even though we don't want to test everything, if we make our code testable, then we will have cleaner code. So aiming for testable code, even without the tests in general, aiming for testable code makes our code better in terms of maintainability, in terms of supporting, in terms of bug fixing, in terms of everything. So aiming for testable code is a good idea, like always. Of course, writing tests is even a better idea, but I am familiar with the most common business practices out there, and I know that most of the time businesses don't have resources or don't want to invest in testing, which is kind of a pity because uh, in my own experience, investing in testing is a very good thing in the long run. So, investing only 10% of your time every week to assert your code will save you so much trouble that you cannot even imagine. If you haven't worked on a project with more than thousands of tests, most probably you don't appreciate tests enough because in my current project we have like 2000 tests implemented, and in our more legacy project built with the same theme, we don't have any tests at all. So in the newest project we started doing more tests, and everyone was super disappointed at first because they didn't want to lose time writing tests because writing tests are kind of boring. Well, that's the ugly truth. So at first they were a bit disappointed because they needed to invest so much time in testing. We currently invest 20 or 25 percent of our time in testing our logic. Well, that's nice, but when some time passed and 1 year later our new project was not that new anymore and we had a lot of bugs to fix, we had a lot of feature requests, we had a lot of work to do, and everyone understood all these tests super were super helpful and super important to save time in terms of validating changes throughout the code, in terms of making the code more cleaner, more better, in terms of writing higher quality code. So most people in my team had to start writing tests had to have more than thousands tests in the project, had to evolve and grow the project, so it needed some time, like I said, a year and so. And everyone was super excited that they had tests. They were super happy and they understood the value of testing. So if you are currently not testing in your codes or if you're not testing at all, I can understand the reasons behind that, because testing, usually to test some code, requires a lot of time, and most of the time it requires like 3 or 4 times more than the actual development of the feature. So if we develop a feature for 1 day, we need to write tests for 2 days, and that's a lot of investment. Of course, that's in the case when we want to have 100% code coverage, which is not necessary, and I believe it's uh, kind of kind of a bad goal to have. It's a little too optimistic to aim for 100% code coverage, and most importantly, you don't need to do that. Good. So, I appreciated tests when I started writing libraries. You may already know that I wrote 3 or 4 tools for developers, for ASP.NET developers, that help with the testing itself. But I was like, I'm writing a code to test some other guy's code, and I need to be sure that that my tools are working correctly. So I aimed for 100% code coverage for this scenario. And what was important is that I, from my own experience, 3 to 4 years ago, I understood how important testing was, because I made so much changes in my in my tools throughout the years, because I wrote more than 1 million lines of code according to GitHub. I believe that's too much, but according to GitHub, that was all the changes I did. So with 1 million changes in the source code, if I didn't have any tests, that would have been a great disaster. And well, I'm not sure whether I could have released even a single version of these tools. So for me, testing is super important. When I started working on my current projects, in my current company, I it was my task to make sure that the CEO understands that tests are important. Usually, you can write and present a graph. The graph looks like something like this, but we can say that if we don't test, our line of coding will look something like this. If we specify that this is time passed since the beginning of the project. So, for example, this is 1 month of working on the project. This is 2 months. This is 1 year, and so on. Of course, it's not on scale, and it's a drawing. And if we analyze the time required for a feature here, so how much time a developer needs to implement a feature. And for example, let's say 1 day, 2 days, 3 days, and so on. And we're talking about the same feature here. So the same end-to-end full stack feature with implementing some data models, some backend logic, and some front-end logic. So without testing, every single feature requires more and more time when the complexity of the system evolves, because with the past time, the system evolves and it becomes more complex. So the feature we need to do, if we have a feature to do, and for example, if the project is 1 month old, I will do it for like 3 hours here. But if the system is 2 years old, then I need to validate way more things to make sure that my new feature doesn't break any old code. So with a 2-year-old system, I will have like 2 days or even more to implement the same feature. So this will be without any tests, because the more complex the system is, the more manual testing I need to do and the more things I may break. So with every feature I may introduce various other bugs, which is kind of a thing that I don't want to do. And the second thing is, if I have tests, let's write it like this, the line will look something like that. So in terms of not having any tests, the complexity grows exponentially, and the time required to implement a feature will be huge the longer this system is developed. But if I decide to start writing tests from day one, and if I decide to introduce tests from day one, then it will take me a lot of time to write the initial tests, to write the tests themselves, to think about the tests, to think about all the edge cases. But what I gain from this thinking is, and what I gain from all these tests, I gain better architect system, because if my code is not testable, mm, if my code is not well written, I won't be able to test it. So I'm going to refactor it to make sure that it's testable enough. And by making the code testable, I'm creating a better code in general. And with better code, it's less probably to add any bugs. It's less probably to make spaghetti code. It's less probably to have code which is not readable or maintainable. So adding features will be easier only because I have testable code. So the code itself is cleaner. So features will be added easier. And second of all, when I add a feature, I can easily validate whether this feature breaks something out or not, which will save me a lot of time. So the graph looks like this, and I use the same graph and I presented this to my CEO, which is the manager of the company. Yeah, CEOs do that, so I don't know why I said that, but it's the manager of the company, and essentially it's the main manager of the dev team, so to speak. So I presented him this graph, and he was convinced that testing is good in the long run, because he may invest more resources in terms of salaries now, but he will save more in the future. So if you want to somehow change the way your company works, you may introduce all this, the same graphic. You may try to convince your manager. I'm not, um I'm not sure that it will work. Of course, that depends on many factors. Maybe your manager will want to have tests, but maybe you don't have times, or maybe the deadlines are not okay. Because I started calculating deadlines with tests included. I started calculating tests in everything, and I explained to everyone around me that tests are important. Lucky for me, the CEO decided to listen, and we now have tests. Of course, we don't have that much tests. We don't have code coverage at 100%, but we have a lot of problematic areas covered, which is more than enough for me. It's better than nothing. So I decided to told you all this because most probably your company doesn't test, or most probably your company doesn't write testable code. Of course, if it does, good for you, good for your company. But from my experience, businesses are always rushing to deliver features and don't care that much about quality and testing. So squeezing and even convincing your manager that 10% of the time for testing is good enough. 10% of every week will eventually lead to a good code coverage of the main features of the system. And that's the most important part, because we don't want to have everything covered. We want to have the hot part of the app, the part that the users use the most, covered. Then that's the most important thing here. Good. So what kinds of tests we have? What are the most used types of tests? Well, first of all, I would like to open this link here, because this link here lists a lot of tests, types of software testing. So if you decide to take a look, you will overwhelm yourself for sure, because you have unit testing, integration test, system, sanity, smoke, interface regression, beta acceptance, performance, load, stress, volume, security, and so on and so on. Frankly speaking, some of these testing kinds are new to me, and I don't know anything about them. That's because some of these testing kinds are suitable for very rich companies. Introducing all testing types to the system means one of these things. First, the data of the system is super important. The data of the system is like mission critical. Having no bugs is mission critical. For example, if you are creating an AI for car driving, it's super important to assert your code in such system, because otherwise people may die on the streets, and that's mission critical for sure. Another thing is, if your company is super rich and can allow investment in so much testing, for example, Facebook or Microsoft. Facebook or Microsoft are super famous for the fact that they have three quality engineers, quality assurance engineers for each developers. That's three QAs for every dev. That's quite a lot. For example, in our team, we have two quality engineers for 9 developers. Two. And now we're searching for a third one, because our quality assurance engineers are a little bit overwhelmed. But nevertheless, it's important to know that even with our case, when we have 9 developers and two or three in the near months quality assurance engineers, even in our case, we are super happy, because we managed to reduce the introduced bugs from 20% of the issues to 3% of the issues. So we introduced 20 we last year we introduced 20 bugs for every 100 features, and now we introduced 3 bugs for every 100 features. So that's kind of impressive, only with 2 quality assurance engineers. Of course, our system may not be that difficult. For example, Microsoft Azure is way more complex system, or for example, the Facebook front end is super complex. It has a lot of features going on. So it's more important to have more quality assurance engineers. So as a developer, it's not important to understand all of these tests. I've listed the most important tests you may start writing now. Of course, if you want to improve your system, or if you can afford to improve your system, you can introduce some other tests listed here. You can read the article, because frankly speaking, we don't care about each separate kind of test as a developer. But if you want to learn more about software engineering in general, if you want to become a better software engineer, you need to read and you need to know most of the cases here, most of the tests. Nevertheless, let's come back and see what are the most important tests we need to know as developers. And of course, we are going to take a look because the presentation is like 7 slides. It's super small because we're going to write tests and we're going to uh, look at the best way to write tests. This live class has a lot of homework if you're interested in that, if you want to practice or exercise. And and if you don't want to exercise, I have provided the full solution in terms of video recordings on my YouTube channel to all the exercises. It's more than, I believe, 5 hours of video lessons. If you decide to look at them at speed 2, at playback speed of 2, you will have 2 to 3 hours of lessons showing a lot of things validated and asserted in the same exercise. So you may decide to try it yourself, or you may watch me explain how I assert everything. Okay, that's your choice, of course. Nothing is mandatory, but it's, how to say it, it's a good idea to exercise what you learn. Of course, if you have the time. Good. So, types of tests that are important for developers. Let me add that for developers. These are the tests that are most important for developers. First, manual tests. We do that every single time we implement a feature. We run our app, whether it's a web app, whether it's a API, it doesn't matter. We just run our app. We use some tools like Postman to validate the API, or you just click through the browser, click to the front end. Everybody does that. Of course, we may have a quality assurance engineer, manual quality assurance engineer, who will write that for us. That's for sure. Who will test that for us. That's for sure, but nevertheless, we as developers cannot push code without asserting it. Of course, if we're building a backend API, only an API, without the front end, without HTML and CSS, for example, and if we write tests, no matter unit or integration tests, we may never run our API because our tests will cover everything. You will save a lot of time. Trust me, if you create a backend API, you will save a lot of time if you decide to not run your project but just write tests. In my last 3 APIs, I decided not to run them at all. I just write automatic unit tests and integration tests. And pretty much that covers the whole API, and I don't need to start it. And if you don't need to start the API, you save a lot of time. So by writing tests, you save a lot of time. That's important only if you write a backend API. If you have a front end involved, unfortunately, that's not the case. If you have a front end, you need to validate whether clicking a button works, whether filling a form works, and so on and so on. But with a backend API, you may decide to be lazy, and it will be completely fine if you have tests. Okay, so the next thing you need to consider are unit tests. So I assume that everybody knows what a basic idea of testing is. I assume that people who joined this lesson and this all my lessons in general have a little bit of experience with testing, or at least know what testing is. So unit testing, I'm not going to cover the deep theory about each of these tests. I'm going to explain when and why you should do it, and for each and for what component. So I'm going to give you best practices in general. Because a lot of people teach about unit testing, they show a simple method, they show how to install XUnit, how to install mock, for example, or something like that. Of course, these tutorials are great. I'm not making fun of them. These tutorials are great, but most tutorials don't show actual production-ready code. They don't show actual problems by having spaghetti code, for example, or something like that. Good. So unit tests are asserting a single component. For example, I will be talking about ASP.NET applications, but it doesn't matter. a single component of your app in isolation. So you are testing controllers, services, and you may test Razor pages, but pretty much you're going through unit test your controllers and your service layer. If your controllers are super thin, by super thin I mean one-liners with, for example, domain-driven design or clean architecture, and if your controllers have the mediator pattern there, you don't need to do a unit test for your controllers. It's not important. But if your controllers have some sort of a logic, for example, if model state is invalid, return bad requests, return unauthorized here, return some sort of a view model here, and so on. If you have logic involved in your controllers and your controllers are not one-liners, it's a good idea to write unit tests for them to validate that not your API is working, but your controllers are working. And unit tests mean that every external dependency in these controllers need to be a fake. I'm going to talk about that in a minute. Okay, you certainly need to validate your service layer if you want to have a good code coverage. Your service layer, your business logic needs unit tests. You need to validate that because the core logic of your whole system lies here. So if you have some calculations incorrect, or if you have some nasty bug which allows you to, for example, have invalid user data or something like that, this will be the place to have that. So unit testing that part of the system is important. So let me show you the simple block system. Simple block system has some areas here. Admin identity doesn't matter. It has some controllers for articles. We can see that we have some actions with logic. We see that we have some validation here and there. We have some usage of temp data here and there. And we have, so to speak, as little logic as possible in these controllers. So these controllers are written not in a perfect way in terms of architecture, but good enough, because every business logic is extracted to a service. We have services, for example, we have article service, which is doing the business logic of the articles. Every link query is an actual business logic. So if you see a method like that, some people ask me questions, well, is that an actual business logic? Well, it is, because even though this is a link query and it's a one line of code, technically speaking, this is business logic, because if you want to describe this thing without using link and for loops, you will see that you have to have some ifs for the where statement, some storage in memory for the select statement, and so on. So it's an actual business logic, because the business logic here says, give me all the public articles and fetch me only their IDs. That's business logic. It's not a super difficult business logic, but nevertheless. Then we have find articles by user. Find articles which have this user ID, order them by this date time property, and get some mapper configuration from here. So this is essentially business logic, and it's extracted. For taking a look at our controllers, we can see that the controllers still have their web part implemented as logic, which is not a mistake. It's okay to do that. There are better ways in terms of clean architecture, for example. You may see on my YouTube channel that I have some videos on domain-driven design, which I plan to expand to clean architecture, but nevertheless, this is good enough. But still, we have logic in our controllers. We have some node checking here, some checking of whether the article is public, and so on and so on. So this cries for unit testing. Cries for unit testing. And unit testing this means that we need to fake everything outside of this method. What is outside of this method? Somebody may ask. Well, article service is external. We need to fake it. Then the user is external. It's part of the framework. It's not part of the logic here. This is part of the framework. This .user is not part of this method, so we need to fake it. And that's pretty much it. So we need to fake the article service, and we need to fake the user, because these are the external components of the system for this method. And we need to validate whether with fake user and fake article service the logic is working correctly. Whether for an article we have a return type not found, whether if all the checks pass, we have a view result with some article in it. So essentially speaking, we need to validate all return types. We need to test for all return types for various parameters, and we need to validate all the edge cases if there are any edge cases. But here edge cases are, for example, article equals no, or article is valid. These are the edge cases. So we need to validate all returns. Of course, for unit tests, this means that we need to fake this, we need to fake this. We need to fake everything which comes outside of the logic here. That's the important thing we need to do with unit tests. Okay, so with unit tests, let me just show you that if we have a clean architecture or more abstract architecture, for example, domain-driven design. If we go to the web and then the controllers here, we will see that the controllers are super thin. The controllers have one line of code, which is just send something. These controllers don't need to be validated. These controllers don't need to have unit tests. We can add integration tests for this, but no unit tests, because we don't have anything to validate here. Nothing to validate here. Good, so starting with unit tests. Unit tests, controllers and services and other things that have some logic. If we have thin layer of controllers or razor pages, then there is we shouldn't test them, we shouldn't assert them. Next, we have integration tests. Integration tests in the ASP.NET Core integration testing, this thing here, it's very well documented, so I'm not going to cover that much how to integrate and do integration tests, because you cannot do any mistakes with integration testing in general. The problem with integration testing in general is that by default, with the default implementation that comes with the Microsoft's default solution, is that you need to validate a lot of strings because you will integration test. If you're not familiar with that, I doubt that you're not familiar with integration test, but nevertheless, integration test means that I want to validate everything from the beginning of the request to the response of the request. So I want to validate the whole pipeline of my web application, the routing, the controllers, the actions, the service layer, and the database with a single test. That's the integration test. I may add a fake database, that's absolutely fine, because each test needs to be isolated. This is true for both unit tests and integration tests, but tests should be able to run in a synchronous environment. Tests shouldn't depend on each other. Each test should be independent, and if it's run in isolation, it should work. If it's run with all the other tests at the same time, it should work again. So integration tests again may need to have a fake database, but everything else is not fake. You have the routing system, the integration, the controller discovery, the action selection, and all of these features in the MVC framework. The problem with the default approach is that it's a little bit difficult to configure. Of course, it's copy-pastable code for sure, but it's a little bit difficult in terms of validation, because validating integration tests makes you do things like this. Makes you do string checking, validating whether you have div class. You need to create a lot of string checking, which is very error prone, which don't have compile time checks, and so on and so on. Nevertheless, you may decide to uh, analyze these integration tests. They're okay, of course, they work fine. The downside of the default integration tests are that you will rely on lots of strings, lots of strings. This is why I created my tools. I'm not going to talk a lot about them, but they allow you to do full integration tests without a string and with strongly typed assertions. It's very simple to create such tests. I'm going to show you, because these are currently here are some controller integration tests, but you can easily specify, I want to assert my controller, I want to add some user, authenticated user. This controller should call my action, and it should have valid model state, should have some view back, and should return view with some model which passes some assertions. So it's super easy to create an integration, a fully working integration test, because this thing will validate the services, the service layer. You don't need to provide any fake service layer here, because it just have a fake database but nothing else. So it validates the full pipeline. And if you want to validate the full pipeline with the routing, you can do it by using the so-called pipeline test. That validates everything from start to finish. So you can do something like, my MVC pipeline should map this route to this controller with this action and this parameter here, which with certain amount of data in the database and some dependencies should return view with model of type passing some assertions. You may take a look at the block sample here. It has various unit tests, routing tests, pipeline tests, and the integration tests are actually here. So writing a full integration test for an action is super simple. My MVC pipeline should map this route to this controller, which with this data, these articles in the database, should return view with some sort of a model passing some things. So writing integration tests is super easy. You may, if you want, to try it out. Good. So I'm not going to talk about integration tests that much, because there is no place for errors there. You just test the whole system. You mock the database and test everything. It's super easy. If you go with the default Microsoft approach, it takes a lot of string parsing, string checking, not that cleaner code. And if you want, you may check out my tools. We're currently working to bring them to ASP.NET Core 5, but yeah, it takes some time. So with unit tests, you test everything in isolation. With integration tests, you validate the whole system. And with acceptance tests allow you to create Acceptance tests actually validate the business logic. So if you have multiple actions, you validate them all at once. Which means that, for example, a user registers, then a user logins, then a user changes a password, then the user logouts, then the user logins again with the old password and receives an error, a wrong password or something like that. Then the user logins with his new password and receives status code OK with success. So this whole thing is an acceptance test. So uh, if you want to create an acceptance test, you need to validate multiple routes, one with the results from each other. Good. Then we have, once again, these are the most important things developers care, the most important tests developers care. We have performance, load, and volume tests. I'm not going to talk in detail what's the difference between these tests, but most importantly, these tests just validate whether your system can withstand a certain amount of users, concurrent users. Usually, for such tests, you will require an external tool and you will require a staging environment similar to the production environment. So, for example, if your production environment has 128 gigabytes of memory, you will need the same for the staging environment. Otherwise, your tests will not be relevant because if you have different hardware running the app, you won't have correct results. So it's very rare to see performance and load testing done correctly because it requires the same setup as the production environment, and that requires money and requires some sort of investment. Of course, if performance is mission critical, like it was uh, 3 months ago, we were expecting a double increase of users, like 5,000 users concurrently on our site at the same time, which we never experienced before. And we were expecting that our system will crash. So I had to create some performance tests. I had to run a test. It's very easy to run a performance test. You just need to have the URL and you need to pay for a tool to do that for you. So it's very easy to do a performance test. The problem with that was that I didn't have a staging environment. So I had to do the test on my production environment and I had to do it during the night when users normally don't access our site. So if I crash the system, it doesn't matter. So I ran a performance test and I saw that our system could withstand only 3,000 users and we were expecting 5,000. So that was a problem. So we needed to increase the hardware, introduce some caching here and there. Well, we solved the issue and we managed to withstand all the users. But the idea here is that usually you do performance testing when you have a mission critical situation or when performance is part of the system design, part of the system's idea and business plan. Good. Now, let's talk about fundamentals of testing. First things first, test code should be clean because I see a lot of people making their code super clean. For example, this controller looks quite nice. It's completely okay. I don't see a lot of problems here. Of course, we have some, but this controller is quite nice. It's clean, everything is tidy, it's readable. Then if I go to the article service, for example, here everything is also tidy, readable, nice, which is great. But people tend to forget about the clean code rules when they write their tests. And that's super. It's not a good idea to do that. It's not a good idea to neglect the tests in terms of their code, because test is again code. If you have clean code in your test code, it will be easier to create tests in general. And I've seen a lot of guys copy pasting assertions, copy pasting mocks, not doing their tests as clean as possible. And you will see in a minute that when I try to introduce something, I always think whether I'm following best practices in the test code itself, because that's also super important. It's super important. Then follow the AAA pattern. The AAA pattern, you should be familiar with it, but nevertheless, it's arrange, act, assert. Follow it. You may comment your code if you like. You will see it in a minute, but follow this pattern because it structures your tests. Of course, it's not necessary because, for example, if you decide to use MyThoo, uh, the test will be one-liner. So writing as arrange, act, assert here and there is not that important, but still this tool follows it because even though it's not shown directly, first you arrange everything. Here it is. You arrange your controller, your user, your data, then you create an act, and then you assert. So it follows everything. We can see arrange, act, assert. So it follows that. Of course, if somebody wants to write arrange, act, assert, it's still fine. You can write it here, you can write it next to it, you can even write it with variables, it doesn't matter. It's still doable, but follow it. Follow the pattern. No matter your tools, no matter your use case, follow the pattern. It's a good pattern to follow because it structures your code and make it a little bit cleaner. And if you structure the arrange, act, assert your tests with the arrange, act, assert pattern, it will be very easy to extract common places and make your code cleaner. Good. Next thing to consider is never assert already tested things. Already tested things. So what are already tested things? First of all, don't validate whether a link works correctly. Don't validate whether the query is sorted. Don't validate whether anything works correctly. Don't validate whether take returns the correct number of elements. You may validate your business logic. You may validate that your query returns everything sorted by published date, but that means that I'm validating this part of the business logic and not this part. Don't validate entity framework. Don't validate that entity framework stores something in the database. Don't validate anything besides your code. Consider that all the external code is already tested. So don't validate that if you add something to the temp data, for example, then in the view HTML, the temp data is working. The Microsoft team already tested that. Don't validate that the model state shows is valid if you add an error in it. Microsoft already tested that. So don't validate whether redirects work correctly. Validate whether the redirects are to your specific action. So validate your own code. Validate this thing, validate this thing, validate this thing, validate your ifs, your logics. Never validate external code. Never validate that the controllers are working correctly. Never validate that ASP.NET Core is working correctly. Never validate such things. You may validate these attributes here. So by using reflection, you may validate the HTTP post for the create is only for authorized users. That's important because otherwise somebody by mistake may delete that. And by deleting that, it will make the whole business logic exposed. Some data may be exposed and so on. So make sure you validate the action attributes. These are important. Yeah, the thing is never test external code because they are already tested. Never validate that the C# code is working correctly. Never validate that the the anti-framework is working correctly or that ASP.NET Core is working correctly. They are already tested. You validate only what you return and only your logic. Next, we need to have some loosely coupled code. Otherwise, we won't be able to test things. And here in this project, we have some problematic parts which don't allows us to test and validate things. For example, let's say in the home controller, a typical mistake is that we have a new article service here. So even better would be to have like something like this, var article service equals like this. And here it is. This is even less appropriate design because we don't have anything related to dependency injection. Nevertheless, most developers are familiar that they need to extract services in their private fields, and that's completely fine. Most developers know that. So I don't expect anybody to create such error in his code. But consider that this project grows, and it grows a lot. And by growing the project, it will be more and more easier. It will be way more easier to introduce some dependency like this. Of course, in the controller, most people know that this is a mistake. But what about the services? For example, not article, image service. So image service, we have some image.load here. We have some web client. We need a web client. We go to Stack Overflow and ask Google, hey Google, how to download a file with C# because I need to download an image. So they say, well, instantiate a web client, and you open this. You see that it doesn't have any interface, so you say, okay, I just create this, and I call download file task async. So a typical developer, which is not that advanced, which is still learning best practices and so on, will do that mistake without any problem. And the same developer may be familiar with this error that the controller doesn't have to instantiate the services, and the services should come from the external world. Nevertheless, this developer may make a mistake about this thing here. So, what is loose coupling? Loose coupling means no direct communication between classes. No direct communication. This is direct communication. The image service directly uses the web client service and directly uses the file system and directly uses some image processing library, which is image#. So to speak, this is not a loose coupling, and if I need to test this, I will have a bad time. The articles controller, let me take a look. Again, here it is, we have a random. Somebody thought that it will be a good idea to have a random article. So the random article here will return, we'll have a random dependency here. And again, a more junior developer may decide that this is completely fine because he needs a random, he creates it. Yeah, so we need to have loose coupling. Loose coupling means that we don't have any direct dependency to anything in our logic. Currently, we have dependencies everywhere. Here, we don't have here, but it's a simple method. Here we have a dependency to the framework because we use ASP.NET Core's user. And that's problematic because we have an actual dependency to the user. That's problematic. So we need to have either loose coupling or a way to easily replace the dependencies. That's super important. So what we need to test? We need to test interaction between objects. So we need to validate. If we validate this thing, we need to test not whether the article service is working correctly. If we unit test this method, we need to validate that the article service is called with a certain page size and that the articles are a certain number. Here is the number 3. So we need to validate not the article service directly, the article service itself, because we are currently testing the index. We need to validate the communication between these two objects. So we don't care whether this service is fake or not. We care whether the communication is correct. So what is passed to it? Here, we don't care what is the username, what is the identity. We care that this method returns a view with this model. So the connection is we want to see whether the view has a username. So the connection between these things. We don't care how the view works, how the view method works. We don't care about that. We don't care about the produced HTML. We care about the connection. And I'm talking about unit tests, of course. So we need to fake the user and validate the connection between these things. User controller, get profile picture. So here we need to validate the communication here. The communication is with the file system. So our logic is format some image destination, some file path, save it to the file and return it. Read it from a file and return it. So if we want to test and assert the logic of this method, we don't care whether the file system actually saves something to the file system. Microsoft already saved that. We care about the communication between these two classes. We care about the controller and the communication with the file system. So we need to validate whether the controller passes the correct user image destination. And that's the important thing. We don't care about the file system at all. We care how our logic interacts with it. So we need to validate this thing, and we need to validate the result and the result responses. Change profile picture. Again, in this situation here, we don't care whether the picture is actually updated. We don't care about that. If we cared about that, it would be either an integration test or a unit test for the update image method. But no, we're currently testing the change profile picture. Changing the profile picture is doing some validation of the picture URL, then we find some destination and then update it through the image service. So the idea here is to validate whether this method communicates the correct destination here and provides the correct picture URL and provides the correct user image destination. So to test a method in isolation means that we need to validate how this method interacts with other objects or other methods. We don't care if the other methods return correct results or are working correctly. We care whether this method provides correct data to the other methods. That's the important thing. Let me see another example. For example, here, delete. We don't care whether the article service is returning correct articles by this user ID. We care whether we provide the correct user ID here, and we care what will happen if the user is not administrator. So we don't care whether the article service and the user are actually authenticated. We don't care whether the article service actually calls a database. We don't care when we test this method here. We don't care whether the user is actually authenticated with a real cookie. We don't care about that. We care to see that the user is an actual administrator, so we need to fake that, and we need to fake the article service to return an article with a specific user relation. And that's it. We don't care about anything, how it works. We don't care the internal working of the external methods. We care about the communication of the method. Here again, confirm delete. We care whether this method passes the correct data, whether this if returns correct result, whether the deletion is code. We don't care whether an actual deletion happens on a database. We care whether this delete here is code, whether we code this method. And we care whether we add something to the temp data. We don't care whether the temp data actually works, because that's an external code, but we care whether we passed the correct message here. So these things are super important. We test the interaction between the objects. We don't care the inner object of the current unit test. Of course, if you want to test the everything, the whole system as a single unit, then we can do integration tests, and that's not wrong. As a matter of fact, if you don't have a lot of time to test in your theme, what you can do, how you can prioritize testing is, first you can integration test, because with an integration test you cover a lot more functionality. You cover a lot more parts of the system with a single test. So do integration tests on the hot part of your app, the most used features. For example, if you have payments, test the payments. If you have a super important feature that is the core business logic, the core business domain, integrate test that, and that's it. So if you don't have any time, do integration tests on the core features. You save a lot of time, but you still have a huge code coverage of the most important parts. So you can skip edge cases, you can skip super rare cases, super exceptional cases. You just need to validate that the common path is working. Then you may add edge cases for the integration tests. Then you may decide to unit test your components, because with integration tests it's hard to see what part of the system fails, and with a unit test you will see what part of a system fails very easily. But still, if you don't have time, integration tests on the core features. If you have a little bit more time, integration tests on the edge cases. If you have even more time, unit tests on the core features, and so on. An exception to this rule is if you have a very complicated algorithm. If you have a very complicated algorithm which is important for the business, you may add unit tests for it. So the most important parts to test if you don't have any time are the core business domain, the hot path of the users, with integration tests, because this way you will have the most bang for your buck. And if you decide to validate, if you have some complicated algorithm, something more complex, not that straightforward in terms of development, write unit tests for it. This should be the main goal. Everything above that is nice to have. Of course, it helps with bugs, regressions, and so on, but it's more nice to have. So if you want to have testing on a tight budget, integration tests on core domain and unit tests on complex algorithms. That's the important things. Okay, so the next thing is test state changes of components. Test state changes, for example, does anything changes state here? Well, you may say that something is deleted. Yeah, but that's deleted from the article service. That's an external component. We search for state here in this method. So a state change is the temp data. This is a state change. This is a state change. Here we don't have a state change. Here we don't have, we return data. Uh, Here we have a state change. Again, the article service edits an article, of course, but that's an external component. If we want to validate the state here as a unit test, we can validate the temp date. Again, I'm speaking about unit tests because integration tests are easier. They just test the whole thing with a fake database in isolation. That's it. But if we have an article service and we want to unit test that, we can validate a state change again. Here it is. We can validate whether this method actually adds something to the database. So we can validate whether the save changes is code. So we validate this thing. We validate the state change here. And the state is adding an article to the articles and calling save changes. Here we have a state change too. So state changes should be validated as well as interaction between objects. And here is another advice. Fake as little as possible, but remember, if you're using unit tests, you need to fake everything external of your method. And if you're using integration tests, fake as little as possible. For example, in integration tests, you will fake um, you will fake database, you will fake external providers, for example, payment systems, you will fake mail senders, and so on and so on. So with integration tests, you will fake all these things. Of course, what you can do is you may have an actual payment testing environment, so you won't fake the actual payment integration, but you have um, testing environment for payments. You may have testing mail senders and so on, but the problem with this is that you are going to spam a lot of emails on every test run. So it's a good idea to have all the external systems faked. Because usually if you use an external fake email sender, most probably this mail sender is already tested by the company who produces it, and most probably the mail sender will work correctly if they create a quality software. So it's not important for you to validate the actual test, the actual email. It's not important, but it's important for you to validate that you are sending the email to the external system. So fake as little as possible, and integration tests should not fake any internal component of your system. Guys, if you want, I can create a lesson about integration testing too. Just message me or just shoot me a question and I can create a lesson on integration testing, how to make integration testing with ASP.NET Core projects, with my tools, with various scenarios, but still integration testing is a bit more easier because you know that you don't have to fake anything. But with unit testing, that's more difficult because you need to test components in isolation, and it's more difficult in terms of code, in terms of everything. Integration tests are just code this route and validate what is returned throughout the whole pipeline, so it's a little bit easier. Okay, so let's make a quick 10-minute break and we're going to do everything that is everything that may be wrong in your system if you decide to test it. So this testing guide gives every single thing that may not be correct in your solution, and we are going to take a look at the block system, how each of these dependencies and each of these testing mistakes, so to speak, is implemented there, and how we can solve them. Like I said, there are a lot of homework tasks because otherwise it will take us 5 to 6 hours to implement and test everything. But still, if you are interested to see the whole solution everything is solved. No, every single homework is solved and explained and written live. You can check this playlist here, which is on my YouTube channel. I started on the same project without without any tests, and I implemented everything listed in this presentation. Of course, it's a good idea to implement it by yourself to practice what you learned, but still, if you don't have that much time or if you just want to see the solution, go to the YouTube videos. I test everything from start to finish there, and I cover every single thing that may be broken in your system and that may not that make your code less testable and less cleaner. Of course, we're going to cover everything here, but we are not going to implement everything in this current lesson. Good, so let's create a 10-minute break. Let's make a 10-minute break, and we are going to write some code here and there. Okay, guys, let's continue. Everything should be streaming fine. Just quick setting on the video. Good. So I guess yes, please is about integration testing, because maybe that's the only question I asked here. But okay, I will add it to the poll, and if people decide, we may create an integration testing video. For example, as a normal lesson. I believe it's better to be a normal lesson and not a live thing, but it's your choice. Okay, so the testing guide. The testing guide here shows everything we need to know when we want to test, everything we need to look at. So first things first are the framework. The framework is something that we need to be aware of when we create our tests. So let's start writing some tests, and we're going to cover everything because we won't be able to write everything. And like I said, I already have video lessons about writing each test. So just to say it again, on my channel, YouTube, my channel, this channel is going to be replaced. It's going to be coded up soon. Go to the playlists, and here we have code testing. This code testing. So we have a lot of videos about testing, and I implement a lot of these things there. So this is why I'm going to talk in this live session more about the best practices when we write tests and more about what to look for, because the actual implementation is there. So, okay, what we need to create in our tests project, it's a good idea to separate things. To separate everything, first thing first. So this is a given, but nevertheless, I need to say it. Uh, Take a look at this testing sample here. So in my tool, in the samples, take a look at the block here, because block.tests here, because here we have also a good separation of testing, a good um, a good and clean code about testing, mocks, and everything related to testing. So you may take a look at that too. Okay, so we need controllers, we need services, and pretty much that's it for now, because what we want to test the we want to unit test controllers and services. Why? Because our controllers actually contain logic. So writing controllers is testing controllers is mandatory. If we had one-liner controllers, then it's not that mandatory. So what is important here is that the framework we're using is normally going to have some problematic issues when we try to assert it and when we try to test it. If the developers of the framework had testing in mind, it should be fairly easy to mock and fake some of the framework things and objects, but sometimes it's a bit difficult. And now you're going to see that with the current framework, we have ASP.NET Core. So every time we use something from the ASP.NET Core framework, for example, controller user, we need to test it. And testing that is not that easy, unfortunately. So the framework needs to be testable. Microsoft do a great job by making their frameworks testable, but still it's a little bit difficult here and there. So let's start with the most simple case. Home controller. And usually I create home controller tests or test, it doesn't matter. If you decide to go for plural form, use plural everywhere. If you decide to go for single form, use single form. It doesn't matter as long as it is consistent. Okay, so we have using XUnit. In this project, I already added everything we need for basic testing, and that's shouldly, which are just assertions, mock for mocking, and I'm not going to cover mocking here because there on my YouTube channel I have a video about mocking, and we have Microsoft Anti-Framework Core in memory. I'm going to show only the basic idea about mocking, and that's it. And that should be more than enough. Okay, so home controller test, we should have some fact here and public void or task depending on the test. Let me add it. Of course, this test is super simple, but we should start somewhere. We're going to test this thing here. We're going to test the view. Super basic. So home controller, you may add underscore if you like, should return view like this. If you have parameters, you may specify with no ID, for example. You may add underscores, you may skip them as you wish. Usually I don't like underscores in a C# language, so I skip them, but if you decide to have more readable test names, you can use underscores before the subject of the test, the return result, and the parameters you're going to use. Then we need to add arrange act assert. You may not need to add the comments, but it's a good idea to comment that out. If you take a look at the ASP.NET Core tests for the MVC framework itself, you will see that they comment their tests. And it's not a bad idea because it's way more structured. So testing a controller is super simple. We just need to create a home controller. Of course, I already added a project reference to the controller, so that's why I can see them here. Of course, the result is super easy because I want to see the about result, and then I need to say result should be assignable to, and I can specify view result. Something like this. Good, so running this should return a success result. Nevertheless, that's super simple. Of course, that's not cool, so to speak, but we need to start from somewhere. Once the build is done once, then all the tests will start running fast. Good, so the controller or the framework is testable if we don't use anything from it, because otherwise this home controller may throw some exceptions if the controller itself needs some dependencies, but it works correctly, which is fine. But what about the privacy? The privacy is a little bit problematic because if we want to say, okay, fact public void home controller, let's take a look at it. The privacy action result returns a view with some model with the username. So this is an external thing. This is part of the framework. So the framework, we need to understand how to fake the user on the framework. Of course, a quick Google search will do that for you, but it's still there and you need to consider it. You need to make sure that you use the framework in a way that it's testable. Should return home controller index should return view like this. Privacy should return view with model, something like this. So apparently pretty much everything is the same here, but we are going to say code privacy. The problem with that is that we are using a user and it will throw some exception. How to validate that? It's super simple. We will see that this throws some object reference not set to an instance of an object. If you debug that, I'm not going to do it. If you debug that, you will see that the user is no. So the user is no, then the identity is also most probably no. So how to do that? This is the problem with the framework. We are currently depending on the framework. So no matter what framework you use, Blazor, ASP.NET or whatever, you need to have an idea how to mock it or how to test the framework itself, because the framework is a dependency. So the setting of this is a little bit difficult because it's not that straightforward. You may analyze what happens here, but it's not that straightforward without searching on Google or without analyzing the source code of ASP.NET Core. What you need to do is most of the time, and this is true for ASP.NET no matter what you do, every single component in ASP.NET has a context class. So for the controller, that's a controller context. The controller context allows you to specify some things in the context. Then the controller context gets the user from the HTTP request cookies or token or header or whatever, but the currently authenticated user in the controller comes from the HTTP context. So HTTP context, then what we need to do is we need to create some HTTP context, and here we can create the actual user, new claims principal, like this. And then in the claims principal, we can add an identity, new claims identity, but not here, more in the constructor. And here we can add, and here we have a user. So now the user won't be no, and this should run. Yeah, the test passes, but we are not testing everything here. Wait a minute. So the arranging of the controller must arrange the HTTP context, the user, everything, which is kind of problematic, but still. So the next thing I need to do here is validate whether the view result is okay. Result should be assignable, var view result equals to result which should be assignable. View result dot model should be assignable to the privacy view model type, like this. And then we should specify that model dot username should be something, but we don't have any username, so let's say that we want to have test user. So how to add a test user? Well, we need to add a claims identity here, which will have the user like this. So I need to provide new list of claims, which will have new claim, and the claim types dot name should be test user, something like this. It's super super difficult to set up something so simple in ASP.NET, but it is what it is. At least it's testable. So it's not that difficult to add a user with a role, with the ID, and so on. So at least it's testable. And as we can see, now the user is working correctly. So I'm not here to teach you about writing tests on the controller, because this code can be copy pasted from internet. Of course, you may not understand what's going on, but pretty much every component has a context object, and the user comes from the HTTP context. So the controller has a context about it. The context contains the HTTP context, and the HTTP context has a user. Users in ASP.NET Core are these objects, claims principal. The claims principal has multiple identities. In this case, I'm creating one, and each identity has multiple claims. Each claims defines the username, the user roles, and so on. So if I want to create an administrator, claim types.role, I can create administrator like this. So this is a way to create a user which has a username test user and administrator. You can also create a user with identifier like this, for example, some ID. So this is the way to create that. But still, so this test here is not that clean because we have a lot of code writing here. Most probably I will write another test with authenticated users. So what I'm going to do is I'm going to create a folder which will be called either infrastructure or extensions. But infrastructure is good enough. Infrastructure is good enough. I'm going to say controller extensions. And I'm going to create a static class saying something like, give me a controller with test user. This the controller. So I'm making my future tests easier. And you will see how in a minute. So here I'm going to just copy paste this, and I'm going to say controller dot, one moment please, where the controller is a controller, actual controller. Yep. And I'm going to say controller context equals this thing here, include everything, good, return the controller, and that's pretty much a good extension method which allows me to say something like create a new controller, and add test user like this. It's super simple and it's way more clean this way. And by adding this extension, I can now easily assert a controller with authenticated user. So always keep in mind that you can improve your test code too. And if I see that I'm copy pasting some more code, I will create even more abstractions. You will see in a minute. Then controller extensions. Look at this thing. So this is a magic string. So we can improve this by adding a class, add new class, saying test constants. This test constants class will contain common test constants. For example, test user name equals not test user, like this. So this will be common among our tests, and I'm going to specify it like this. User string user name equals test constants dot test username, like this. Of course, we may add some rows. Test administrator row equals administrator, and so on, depending on the use case. I'm not going to add that. You can also specify string rows, row equals some default row, for example, like this, and you can use it down here. If you need an ID, you can provide the ID too, and so on and so on. So you can easily add here the test constants, and you can easily create controller with a test user in row, for example, moderator, by specifying the row here. Otherwise, it will be an admin or, for example, string empty, so that the row is not valid, like this. Nevertheless, I'm not going to add a row currently because we don't need it, but you should get the idea. Good, so currently my tests look pretty nice. Uh, everything is validated. And instead of shouldly, you may use fluent assertions. Both are completely okay. Shouldly. For example, fluent assertions allows you to say something like this should not be empty and should contain something. It's very easy to use fluent assertions because shouldly gives you just some should extensions, but the other thing will give you something like result dot should be view result and model should be whatever. So it will be chainable, easily chainable. Here you don't have of course, you have some sort of chaining, but it's not that chainable. You don't have and, for example, or something like that. So you can say dot model equals that and so on, but it's not that chainable like fluent assertions. Fluent assertions is a bit more chainable. Of course, I made it work, so yeah, it's okay, but it's not readable because result should be assignable to view result. Dot model should be assignable privacy. Dot username. I believe it will be better if you have and here so that it's more readable, but nevertheless, it's good enough. If you want, create one-liner assertions with fluent assertions or shouldly. The best approach here is fluent assertions because it's more chainable than shouldly, but nevertheless shouldly works fine in the most common scenarios too. And if you don't want to use any fluent assertions, you saw how you can do it line by line with variables. It doesn't matter. All ways are completely fine. Personally, I prefer to use chainable methods because it's more readable this way, but nevertheless it doesn't matter as long as you're consistent. Okay, so the framework is this is the problem, but then we have another problem, and that's glue keywords. Glue keywords are new and static. Every time you create uh, a new thing somewhere, you're glued to that thing. So let's see the new in the home controller. Here it is. I cannot test the index method without actually connecting to the database. Here it is, because the database is also glued. And this is a problem because I cannot create anything and I cannot assert that. I cannot assert anything I have the new keyword except in cases where the new keyword is with a plain old COR object or a POCO model like this one. So if I'm using a new keyword with something that has other business logic, I cannot test that with a unit test. So it's very difficult to have this index method unit tested because I can do because I have a glue here to the article service. So the glue keywords are new and static. Keep in mind that the new keyword here is completely fine because I don't have any logic. I just have properties, so it's completely fine. It's easy to test that, as we saw. We saw that we can test that, but in terms of the article service, that's more difficult. Good. So let's fix that. First things first, everything should come out externally and should be replaceable. To make a class replaceable, we should use an interface. Most probably you are already familiar with that. So to make that completely replaceable, we're going to add it from a constructor, a classic dependency injection mechanism. So using await this article, and that's super simple. So now we can assert that. We can assert that by providing a fake article service. That's the important thing here. So let's go to the test and create a folder fakes or mocks or whatever you like, but fakes, mocks, it doesn't matter. And I'm going to use a simple fake first, and then I'm going to recreate it with mock. So I'm going to say something like article service fake or mock or whatever. I named it fakes, so let's name it fake. So the easiest way, but the most difficult, and you have a lot of classes in your project, so that's not the most appropriate way, is to directly implement the interface. Just after Visual Studio wakes up. So we can directly implement the interface. We need to implement everything. The problem with this approach is that we will have a lot of implementations here which are just throwing exceptions. Nevertheless, that works. And now, by changing the home controller, my tests no longer compile. So what can I do? Well, I just provide some no's here because this method doesn't use the article service, so I don't care. Let's create the test about the index. So let's see what we need to test. We need to test the communication with the article service. So we need to test whether if we add here, whether we add the page size 3 here, and whether the view returns articles again with page size 3. That's the external communications. So the interactions for this method are with the O method and the view method. So the O method we need to fake, the view method is already testable because of Microsoft. So what we can do is we can say something like this: public int page get set. So we provide the page here because when somebody calls the O, we want to set the page like this to make sure to be able to validate whether the page is correct, because what we need to validate here is that the page size, oh sorry, that's the page size. So let's go here and say page size. We want to validate the communication of the home controller to the article service. So we need to validate the page size and whether the O method was called. How to validate that? Well, it's super easy because we can validate that by returning by just saving the page size here. Okay, so what we need to do now is we need to return new list of enumerable of temp model, but I don't want a task. I can say task completed task, return new list of the model like this. No, not completed task from result, sorry. What's the problem here? Yeah, okay. Numerable. It's very problematic to to create fake things because you need to constantly solve things like that. This is why it's better to use a mocking framework, but let's use it in a minute because I want to show you the straightforward way. Okay, so home controller index should it's not index, I believe, and this is about first things first, and this is index. So home controller index should return view with correct articles like this. Again, we have arrange act assert like this, but this time we're going to say new article service fake because we want to provide the fake here. Then we're going to call the index, and then we are going to assert a couple of things. First things, we need to have article service, which equals this thing here, like this. Then I would like to assert that the article service page size should be 3, because this is the controller page size. Of course, this is not a bad idea to be extracted to controller constants. So I see that I have a problem and not that cleaner code because I'm repeating myself. So I can say public const int home index article page size equal 3. And then I'm going to fix that both here in controller constants like this. I can skip that by specifying using static controller constants. This is also a good idea because it will make constants not that ugly. And next thing is fixing it here too. This way, if I, by not repeating myself, if in the future this number 3 changes to something else, my tests will continue to work because I won't need to fix my tests to fix my code. So using static controller constants, controller this should be public. Yeah, okay, like this, and I can say home index article like this. So the page size should be this. You can see that we're validating whether the controller passes the correct parameter to the article service, and that's the important part here. We are validating the interaction between objects. So should return view results, and the model should be assignable to a numerable of, what's the case here? Oh, I have the wrong test, sorry, the wrong method. Should be this one, and I'm going to say it like this, and then I'm going to say it something like return new article service model, but that actually doesn't matter for now, so we don't care about the data because we just care whether the view returns articles, lists of articles. So enumerable article service model like this. This returns article listing service model. So let's validate the thing and let's see whether it works correctly because we may made a mistake. So we have a problem and result should be assignable to view result, but it was task action result. Yeah, okay. So the problem here is that we're essentially calling index and the index is awaitable. So what we need to do is we need to tell XUnit that our code is uh, actually should be awaited. So let's rerun that. And now it passes. So we have the correct page size and the correct model and so on. The problem here is that the fake is not very clean because we have a lot of not implemented exceptions. These kinds of methods tend to grow large. So a better idea is to create something like this. Article service fake, and here you can create a static instance article service like this and use mock. And you can say I want to have a getter and you can specify the mock of the article service here. So what we can say is article service equals new mock of iArticle service. Again, I'm not going to explain mocking that much. I have videos about it and there are various great tutorials on mock as a framework, so there is no point getting in details about that. It's more important to understand the best practices behind unit tests. Good, so article service. Then what I need to do to make the home controller test work is I will say article service fake instance like this, and now I will need to validate the page size of the article service. So this for somehow I will need to access the page size. So what I can do is article service fake. I will provide it here like this. I can even set a private setter because I don't want anyone externally to write on this page size. So what I can do now is I can say article service setup. I want to fake a method and I will say I want to fake the article service O method. Now faking that requires some parameters. I don't care about the parameters and I don't care. I want to make this article service fake as reusable as possible. So I'm going to say it is any int for the first parameter because it has three: page size, and bool public only. So I'm faking the call for any page size, and whether it's for public. This is what I'm doing here. I'm just faking the call. I'm saying for whatever integer the test passes, no matter whether it's 3 or 4 or 5, I don't care whether it's for public or no, just do the same thing. Set up this thing and then we want to have a callback or we want to have a return. So how to return that? Well, we need to have int page size bool is public, goes to something. Essentially, I'm faking the same method because this method has int page size, bool public only. So I'm faking the method. And here I need to provide a return new task of IEnumerable, returns async, return new list of article service model. I can simplify that. So remember this thing about mock. You use mock by faking a method. You provide the parameters for the fake method, and if you want to make it as abstract as possible, just say that you don't care about the parameter, and then specify how you return the data by by providing the same method's signature as above. So as essentially this method signature has an int bool, and we are making int bool returning the same thing this thing is returning. I'm using async because the original method is async. So return new article service listing model whatever. Return it once. We don't care how much data it returns currently, but what we care actually is the page size. So let me return to the normal function body here. Let's return that. And let's say that page size this dot it's a little bit tricky to access. Yeah, we cannot access the because this is a static. It's a static environment. Let me think how to improve that. If we create that to be static, that's not a good idea because if we have static state throughout our tests, in a synchronous environment, it won't work correctly. So what we can do is first we may create it like this so that it won't be a static instance. That's one of the ways. Or what we can do is we can say something like page size or something like that. So we can return two parameters here. That's also an option. So this method may return two things. I'm going to say it article service instance, and I'm going to remove the static first things first. Article service fake, give me instance, give me page size. Yep, that's completely okay. And this page size equals the page size provided in the method. That's not important here. And finally, what we need to do is article service object so that we can get the fake objects without behind this implementation here. I know that for people who don't understand mock that well, this may be a little bit difficult, so make sure you check either mock or fake it easy. Both are great. I have a fake it easy tutorial on my YouTube channel. So good, article service fake, get an instance. So what we can do here now is we can say I want to have an article service fake, which is new article service fake like this. Then I will need to provide the instance here, and there I will need to check the page size like this. So I implemented this method by providing an actual mock using best practices for the data. Good, so fake article service, and so on. So here you may try to check the other glue keyword, and that's the static. In the change profile picture, let's go to the user's controller, change profile picture. It has a static method. What you can do here is you need to extract the image service because it's static. You need to extract it to a separate service. So we need to extract the service, we need to refactor the controller to use the interface instead, and then we need to register the service here in the startup class. So we need to have images service. Of course, this is already done in the videos I told you, so you can decide whether to use it as a homework or not. Private methods, we have multiple ways to do private methods. Calculate optimal size in the image service. So if I want to test the image service, I want to test this calculate optimal size because it has some logic in it, but it's private and currently it's static. So I will need to fix that if I refactor the code. So if I refactor the code to image service, I will need to implement it like this. So let's remove the static first, then I will need to add image service. Like this. And in the image service, I will just need to provide the following methods in the interface. Like this. And we're good to go. Good, so I want to test this calculate optimal size. So I have a couple of options. Of course, I will go to the test and I will create a services on image service tests like we already did. I'm going to say public. I'm going to say X unit. And now I need to somehow validate public void image service calculate optimal size. Calculate optimal size should return, let's see what it does, should return minimum size if or when width is less than it. Good, so we have arrange, act, assert. Var image service equals new image service, like this. How to call the private method? We have some ways to do that. First, we can do a reflection. We can use reflection. That's not a good idea because by using reflection, we will have a lot of magic strings. The second way is to have an exposed object. Exposed object, you may go to my YouTube channel. And you need to search reflection. So I have a lot of reflection. Beautify ugly C# reflection code. This tutorial right here will teach you how you can create a better exposed object by using the dynamic type. It's a very interesting technique which allows you to expose internal and private methods without writing the ugly reflection code. Again, you're going to use reflection, but the end code look more will look prettier, a lot more prettier. Okay, but in terms of testing, we have another solution, and that's internals visible too. So if we add a global assembly attribute, which is internals visible too, and if I say walk.tests, I'm not sure what it's. Okay, yeah, but I need to add it here. Usually I don't add it in classes, but I want to prove the point. So then we mark this as internal, and it's important to say that the method is internal for testing purposes, so that the other team developers on the team will know why this method is internal. And this is not a hack. This is the official C# way to assert private methods which are not supposed to be uh, visible outside of this assembly. And if you want mm, to check that, you can see that the official ASP.NET Core MVC project uses this technique, so it's completely fine. Again, if you can assert private methods through the public interface, that would be better. But this public interface here has a lot of dependencies. Look at that. Web client, image, file. Just to test this logic here. It's very troublesome to test this method here by using the public interface. So it's a better idea to mark it as internal. Keep in mind that if you can use the public interface, do it. If you can assert private methods by using the internal interface, do it. Here we're talking about such private methods that are important and that you cannot assert directly through the public interface because it will be very hard. This way, just create internal for testing purposes like this. And then it will build, and it will build correctly because now the image service can call the method here. So we are going to receive var sizes equals like this, and then we can say sizes dot width. I don't like the small, so I prefer to deconstruct it like this. So width should be 100, like this, for example, like that. Okay, so this way I managed to assert a private method. Of course, let's validate it. What is the build error? Let's rebuild everything first. Yeah, we have I replaced that to a non-static class, so it's normal to image service, initialize field from constructor, and use that. like this. Okay, good. Let's rebuild that. And while it's building, I'm going to find the better alternative. Internals visible to .NET Core projects. Yep, I would like to declare the internals visible to attribute in the CSproj. We need to copy paste this thing here. So I'm just going to copy paste it. Let's go to block controllers instead of or services. Instead of writing this here, I will add it here in the CSproj file. And what I essentially do is I add an assembly attribute. So I'm saying add internals visible to attributes for the assembly and add it for the blog.tests. So let's rebuild that and see how it goes. Looks fine, but what I need to do is, in order to make the web project still working, I need to add image service here, like this, because otherwise it will fail. Okay, let's run all the tests and see how they work. Everything is passes. So for asserting private methods, if you can assert private methods through the public interface, do that. If you cannot, use internals visible to or the exposed object with the reflection. Both are fine. Good. So the next thing is using a database, and pretty much everything else is for the homework. But let's create let's decide what to do with the database. We want to test article service is by user. And here I'm going to show you even more best practices, because you can see that the best practice here is that we have a fake which is abstracted. If later we want to decide not to use not mock, but for example using fake it easy, it will be very easy to replace the mock, because people tend to create all the mocks in the tests themselves. So they start writing a very ugly code, for example, article, fake, new, mock, and they start using mock directly here, which is not that clean. We should follow the same rules we try to follow in our main projects. The tests are still code, so we need to follow best practices here as well. How to follow that? Well, following is done through extracting classes, extracting methods, reusing methods, like you saw here, article service fakes, and everything is extracted. The ugly code is extracted. This makes this code much more easier to read. So if I have a problem with this test, I will see, okay, this creates a fake home controller, and I will see the test very easily because everything is abstracted. The same thing with test user. I abstracted that because most probably I won't have a problem with that code here because that's a generic code. So it doesn't have to be in the test itself. If I have a problem, it will be something along the lines. Let's just add the test username here because that was not correct in terms of quality. Good, so the next thing we want to test is we want to assert the article service is by user method. The article service is by user method has is by user method, is by user method, is by user method. Here it is. So it's not is, it's just by user. This should return some model by validating the articles Yeah, okay, this checks the database for articles, then validates for specific user ID, and returns article for user listing service model. Okay, so the problem here, first things first, is that we have, oh, sorry, is by user. The, here it is, sorry, this was for the next, for the automapper. So is by user, by ID and user ID, this should return both by checking whether an article is by user. It's very simple business logic, but we need to assert that. To assert that, we need a database, but first let's go and create article service tests. I'm going to add here a class article service tests. Good. Article service tests. Then I'm going to add xunit and I'm going to add fact. Public void is by user. Let me check. Calculate optimal size. This shouldn't have the name home controller because I'm in a home controller test class. It should be enough and it should be more than descriptive. Where is this index? So good article service test is by user should return true if article exists. Good. The other way around, if the article does not exist, it's very easy to assert, but we have a database problem here which we need to solve. So let's take a look at the is by user. We have a database and the database is once again not provided. So this is a quick fix and an easy one. So how to provide the block DB context? We need to decide which kind of in-memory database we are going to use. We have two options: the default implementation of the in-memory database, which it comes with Entity Framework Core. The problem with that is that this in-memory database doesn't have relationships. They don't work with constraints. You have relationships, but they are not validated. If you want a SQL-like database which works with constraints, validations, relationships, you should use SQLite. If you go to Google and say something like anti-framework core SQLite tests, you see that you can easily test it by like this. So it's not very difficult, but it's an effective way. But you need to cover connections, close them, and so on. It's a bit more difficult, but you can also use in-memory. In-memory, so it's not in this article. Nevertheless, you can use the in-memory provider. So these are two options you can use. Usually I go for the in-memory database because I don't care about relationships. I don't care whether the database works correctly. I just care whether my logic works correctly. So the in-memory database is good enough. Of course, in some scenarios you may decide to use SQLite because of the relationships. So the problem here is that we have arrange, act, and assert. So to arrange the database, we need to say something like new block DB context, but that thing requires a connection. That shouldn't be used, so I'm going to remove that. that thing requires a connection because this is an invalid DB context with this constructor, so I'm going to remove that. The connection should be provided by these DB context options. So what I can do here is I can say var options equal this thing. This is from the Microsoft documentation, so it's not something super special. Use dot in memory article service DB context use in memory extensions is something that I'm trying to get, but apparently it's in another namespace like this. Oh, sorry. I need the builder class of this thing. So I need it like this, and then I can say use memory database, and here I need to provide some database name. Each database name should be unique for each test, so I can just provide name of is by user, the name of the test. This will make sure that the database will be unique. Well, it's a little bit tricky to say that for sure, but I can say article service is by user true, something like that. And then if I just say dot options, I can provide these here. Okay, that's kind of fine, but the problem is that this has a lot of arrange code which will be used in every single method which has a data access. So a better thing is to add a class saying tests with data. You may specify, you may add it to be abstract like this, and you can create something like protected tests with data constructor, and you may provide public blog db context data get. And in the constructor, you can say something like this. Well, in the constructor, we can say something like this here, but the name will be a GUID like this, so that every single test will have a separate database. That's good enough. You can also do a method public static public blog db context create method and so on. That's also fine, but this is a good way to validate things because you want each test to have a separate database, and XUnit creates a separate, for each test instantiates the class. So it's completely okay to leave it like this. Of course, you can create a method, for example, you may say it like this: get data, string database name, and you can make it like this. This is also fine, and you will provide the database data here, like this. This is completely fine. But it's not the only way. You can do it like this, and it will be also fine, completely fine. So this data. As you can see, I'm abstracting classes. I'm following best practices even though I'm writing my test code. So I have the data. So every time a test needs data, I just do it like this. And I don't care how the data is done. Here I use in-memory database, but I can easily make it SQLite. And I can change it with one change of one changed line of code. So it will be very, very, very easy. And again, it's abstracted. And in my test, which is article service test, I won't care about database infrastructure because that will be abstracted and that will be outside of the tests. So I will care only for article service, which is new article service. Here I can say here is the database. Then what I can do is in the base class, I can say something like public void add, and I will say params object data. This dot data add range data, and this dot data save changes async like this. And it will be super easy in the here to add some data. I'm just going to say this add, and I'm going to add. Okay, let's name it a little bit better because I don't know what I'm adding, but this way I can easily say, okay, create a new article. The article needs to have an ID of 1 and user ID of 1, for example. Then I'm going to say article service is by user, which is a task. So I need to change my method. Await result equals article service var result equals, sorry, equals is by user, and then I can provide the data above, and then I will say result should be true like this. So let's validate whether everything we set up is working correctly, and we are pretty much done. But you can see how I thrive, and I try my best to. So the database is working. Here it is. I tried my best to make everything uh, as abstract as possible, and I can easily introduce new features to the tests. But you can see that the tests themselves focus only on the test data, the tests act, and the assertions. Each test is super clean because they don't focus on any infrastructure codes like creating mocks or creating uh, databases or something like that. Everything is abstracted. All the fakes are abstracted here, so the ugly code related to the fakes is extracted to a separate entity, and the database creation is also abstracted like we see here, which is also super nice because we have tests about we have super clean tests which use data. Now what we can do here is we can say const int article ID equals 1, const string user ID equals 1, like this. So I prefer to make it like that and then use it like this. Again, for another test to validate whether it should be false, I can say I would like should be false if article does not exist. So I'm having a bit of repetitive code here. So what I can do is I can extract private void add articles, which will add these things like this. So I can easily just say add articles, and then I can extract these constants to be private for the class because I'm using them throughout the whole class. And I'm going to. So you see how I try to make the code better and better and better and better. And I extract everything I can do. Okay, so the next thing is let's validate whether this false thing works correctly, and we're pretty much done. So I'm going to say I want to validate whether the article SD is by another user. So let's run all the tests. And we see that everything is working. But the testing infrastructure and the testing classes are very well designed now. Everything is super clean, and each test just do what it needs to do for the test and nothing more. It doesn't create any infrastructure or any other thing that is super ugly. For example, like this. Imagine having to copy paste this thing all over the place. Or for example, like this. Having to copy paste everything like this. Okay, so the next thing is the automapper will be also for homework. Don't worry, I cover it on the YouTube channel, so we don't care about that. Good, so the testing guide. The next thing we need to be aware of is the file system. The file system should be extracted behind an interface, the same way we have an article interface. So the file system should have iFileSystem interface. You see it in the videos I provided. Third-party libraries, you need to prepare them and you need to have a way of testing them. So make sure that these libraries are testable. System resources like datetime also should be behind interfaces. Configuration should be behind interfaces. There are built-in interfaces. So let me show you what are the problems. So every time we use automapper in our services, for example, this thing and for example this thing, this should be abstracted behind an interface. Fortunately, automapper already has an interface. The file system is in the images service. Here is the file system, open right. This should be behind an interface. This is a direct dependency, so it should be behind an interface if you want to test this method. Otherwise, it's not possible. The same applies to the web client. We should extract the web client behind an interface. Otherwise, it's not possible. The third-party library image sharp 2. It should be behind an interface. Otherwise, it's not possible to assert it. We have a file system here. Again, it should be abstracted behind the interface. So all these dependencies should be abstracted behind interface the same way we did with the article service and the same way I created iImage service like here. We should abstract everything. iFile system, iDatetime provider, iWeb service, and so on, iRandom generator, and so on and so on. So in this live class, I explained all the best practices behind the testing, all the fundamentals and all the important aspects. I explained what to test and what not to test. So I explained the whole theory and the approach for testing. I explained how to sell the idea of testing in front of your managers, Hopefully it will work. It worked in my situation. Uh, I explained how to test on a tight budget, what to focus on. So, yeah, I explained a lot about testing in general, and I gave you a testing guide for which you need to. I gave you all the components which are making or breaking your tests. So, these things listed here, make sure you check them out all. If you have the time, do the homework. Otherwise, just watch the full solution here because all of them, the full solution shows all other techniques as well and helpful techniques like the ones here, abstracting the tests, because that's super important. Having to write a new test should be super easy without copy pasting a lot of infrastructure. You should have different all tests should look very similarly. So the important thing here, oh, also make sure you use the theory whenever it's possible because it allows you to reuse tests. So make tests as abstract as possible. Let me show you that with my tools, but nevertheless the same concept comes from XUnit and it's applicable everywhere. But if I take a look at the tests of the, for example, some articles controller, we will see that here I'm creating an abstract test because I'm providing every parameter from here and I'm providing all the parameters above the test. I'm giving different parameters and essentially these are three different unit tests for this articles controller. So make sure you use that whenever it's possible. Yeah, so that's pretty much it. You still have a lot more to learn if this is the first time you see tests, but I cover a lot of things and a lot of best practices, and I solve all these homeworks from start to finish in this video series here. So make sure you check them out because you will learn a lot more about testing. And like we said, I'm going to create, if the community decides, of course, I'm going to create a video about integration testing too, because that's also a cool thing. But keep in mind that integration testing can be done in less than an hour. So I can explain the whole concept behind integration testing in less than an hour. And if we're using my tools, I can test the whole application in less than an hour. I even have a video about that in my YouTube channel. It's for .NET 2.2, but it doesn't matter. It still works. It's the same concept. Everything is the same. So it's one of the first videos I created. How to test ASP.NET Core applications. So if you decide to, I test the whole blog in less than an hour. So if you decide to learn how my tools work, you may check them out too. But that's not important and that's not necessary. Okay, so if the community decides to have a video about the integration tests, I will create one, but it will be shorter than this because unit tests tend to be more difficult than integration tests, and unit tests are I cannot say that are more important, but are more important for a developer to understand because by understanding unit tests, you actually understand the art of testing. Then integration tests are easier. But if you only understand integration tests, you will have hard time testing your application correctly. So understanding unit tests makes your life easier, and also understanding unit tests make your code cleaner and better. So that's super important too. Because with integration tests, your code may suck, but it won't matter. The tests will still pass. But with unit tests, you need to cover and you need to have cleaner code. Like we saw earlier, I needed to extract services, I needed to remove static classes, I needed to remove dependencies with new and so on and so on. So unit tests force me to use better code. Okay, guys. So I have I have a lot of suggestions for you, how to write tests, how to do the art of testing. I gave you a lot of knowledge which I learned throughout the years with a lot of mistakes actually, because mm, my the testing tool, the tests of the testing tool can be improved a lot, and I learned a lot by making mistakes there. So now I know how to test even better, and I gave you the essentials of and the fundamentals of testing here in this video. Now what is left is just to check some other videos and you will be completely fine in terms of testing. But yeah, you need experience. As for the cats, one of the cats is too far away and the other one is sleeping, but I have an assistant which will help me with one of the cats, I believe. Yeah or no? Well, yep. The assistant is my lovely wife, but she gave me this fatty, this super fat cat. She eats a lot and she's super cute because she always wants hugs, 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 and all of a sudden she starts scratching everything. So yeah, it's a very crazy cat, but she's quite old. She's like 13, 14 years old now, and she is essentially a grandma. So it's normal for her to be crazy. We love her, but yeah. So no, don't attack me. You're alive. I'm making you famous over the internet. Okay, so enough of you. Go jog or something because you need to lose weight. So, okay, guys, thank you for watching. I hope it was useful. And again, I was super surprised by this topic, but nevertheless, I've added a lot of value next to my previous lessons. So I believe it will be very, very useful for you. And hopefully, you will appreciate tests more. And hopefully, your company will start writing tests if it doesn't already. So thank you guys. I'm going to see you next month. And if you have any questions, you know where to find me. You can ask them on Patreon. You can send me messages about whatever you like. Anything related to software engineering, career advancement interviews, salary negotiation, CV reviews, code reviews, whatever you like. Just shoot me a message and that's it. Bye, guys, and thank you for being part of all of this. I truly love you.